Hey guys, so we have just finished talking about ions. We talked all about ions. We talked about how do they form, what are their names, how do we write their symbols, all those things. Now we're moving on to our next target here. Our next target is to be able to name and write the symbols for ionic compounds. So let's go ahead and let's talk a little bit about ionic compounds. Okay, one thing you got to keep in mind about ions is that positive ions and negative ions, they have opposite charges. And you know something about opposite charges. Opposite electrical charges will attract each other. Okay, so what happens with a cation and an anion is because they have opposite charges, they attract each other and they'll end up sticking together because of their electrical charges. Okay, now when they do that, we call that an ionic bond because it's formed between two ions. So two different ions, a cation and an anion, because of their opposite charges, attract and stick together. You end up with an ionic bond between them, and that's what we call an ionic compound. Okay, now when this happens, you always have to have the same amount of positive charge as negative charge. So sometimes they might involve more than just the two ions. Maybe I have a cation with a positive 2 charge, and I have an anion with a negative 1 charge. Well, those don't balance out because there's 2 positives and 1 negative. So what'll happen is you'll end up with 2 of those negative ions, 2 of those anions. So 1 positive 2 will balance out with 2 negative 1s. Let's take a look at some of these real quick here. Let's take a look at a couple of examples of things here. Let's say I'm talking about I've got magnesium ion. Okay, you can see magnesium is in the alkaline earth metal, so you know that its charge, the charge of a magnesium ion, is going to be a positive 2. And then let's say I'm talking about perhaps an oxide ion, an ion of oxygen. Okay, you can see it's over here in the chalcogens. It'll have a charge of 0, -1, -2. Okay, so magnesium has a positive 2 and oxygen has a negative 2. Positive 2 and negative 2 balance out. So this will form a compound with just one of each ion, right? So the ratio between those ions would be just 1 to 1. So 1 magnesium to 1 oxygen. But let's say instead I was making an ionic compound with magnesium and chlorine. Okay, well now magnesium is positive 2 like we just mentioned, but now chlorine you can see is in the halogens. Its charge is only going to be -1. Okay, so how many chlorines, how many negative 1s do we need to balance out a positive 2? Okay, well you would need 2 of them. So in this case, a magnesium ion will form a compound with 2 chloride ions. Okay, so you have to look at their charges, you have to consider their charges to understand how many of each will bond together. And sometimes, especially with the transition metals, you have to pay really close attention because some of these transition metals can form more than one ion. Let's say I have a compound between copper ions and chloride. Okay, well copper can form either a positive 1 or a positive 2 ion. So you really have to know which ion am I talking about. Am I talking about copper with a positive 1 or am I talking about copper with a positive 2? Because if I'm talking about copper with a positive 1, then 1 copper will balance with 1 chlorine. But if I'm talking about copper with a positive 2, then 1 copper will balance with 2 chlorines, right? So you have to pay attention to the charges to see what's going to make them balance out. Okay, and you really have to understand how to balance those charges when you want to be able to read and write the formulas, the symbols for the ionic compounds. Okay, and that's part of our target that we just talked about, is that we want to be able to write the symbols for these ionic compounds, their formulas. So let's look at an example here. I'll show you how I like to do this, how I like to think about this. Let's say that we're talking about an ionic compound that forms between calcium and oxygen. Okay, well, the first thing, calcium, by the way, the cation will always go first in these. Okay, so figure out which one is the cation, calcium or oxygen. The cation is going to be the metal. It's going to be the one that's further to the left on the periodic table, and that'll be calcium. So the first thing I'm going to think about is calcium. And I'm going to ask myself, what is the charge of a calcium ion? And I look at where it is on the periodic table. It's in the alkaline earth metals. and those form ions with a charge of +2. So my calcium ion will be 2 positive. The other one was an oxygen, right? An oxide ion. And so I think, what's the charge on the oxide, right? I look at where it is on the periodic table. It's in the chalcogens, and they form ions with a -2 charge. So my oxide is going to be a -2. Now what I'm going to do is I'm going to look at the charges for each, and I'm going to decide how many of each will balance. You want the smallest number of each that will balance out. So here, calcium and oxygen, these will balance with just one of each, right? A +2 and a -2 balance out. They'll balance with 2 of each. They'll balance with 3 of each, right? But we want the smallest number that will balance, and that's 1 of each, okay? So what I'm going to do, I'm going to write the formula. First, I'm going to write the cation, and then I'm going to write a little number next to it that tells me how many were needed to balance. So how many calciums were needed to balance? Well, that was just 1, okay? Now, if it's just 1, we don't write a number there. If it's 2 or 3 or 4 or whatever, we put that number here as a subscript. But if it's just 1, we don't put it there. So I'm not going to put a number there because it was just 1. Okay. Now, after I write the cation, I'm going to write the anion. And I'm not going to leave a space or anything. It's just, we're going to put them right together. The anion was oxygen. And then again, we'll put a subscript to tell how many of each was needed to balance. And since it was just 1, we're not going to write a number there. So an ionic compound that forms between calcium and oxygen is CaO. Let's look at another one here that might involve some subscripts. Say I'm going to write the formula for an ionic compound that forms between calcium and chlorine. Okay, so again, let's write the cation and the anion. Let's figure out what their charges are. So the calcium, just like it was in the last example, it's an alkaline earth metal, so it'll have a charge of +2. And then chlorine, the chloride ion is a halogen. Where it is on the periodic table, you can see it'll have a charge of -1, so Cl-. So I got to ask myself, how many of each are needed to balance? Does a +2 balance a -1? No, it doesn't. Which one am I going to need more of? I'm going to need more of the chlorines. So this is the way I like to kind of write it and show it in my head. I'll write a second chloride here. So I have 2 positives and 2 negatives. So now they balance out. Let's write the formula. So the cation goes first, Ca. The anion goes second, Cl. Well, how many calciums do I have? I have just 1, so I'm not going to write a number. How many chlorines do I have? I have 2, so I'm going to write 2. So the compound that forms between calcium and chlorine is CaCl2. Sometimes they get just a little bit tricky. Let's say I want to write a compound that forms between aluminum and oxygen. Okay, well, aluminum, Al, if you look at where it is on the periodic table, it's a +3. So Al 3+. And then oxygen, like we just said a minute ago, to chalcogen, so it's 2-. Okay, so now I look and I say, how many do I need to balance? +3 and -2 do not balance. So which one do I need more of? Well, I have few. My charge for the negatives is less. So let me add another one of those. And look at this. They still don't balance, because here I have 4 negatives and I have 3 positives. Still doesn't work out. But now I have fewer positives. Let me add another one of these positives. Okay. And they still don't balance, right? So you see now I have 6 positives and I have 4 negatives. So they still don't balance. But you might be able to see we're getting closer. Let me add another negative. And look at this. Now I have 2, 4, 6 negatives and 6 positives. So now they balance. Let me write the formula. The cation goes first, so Al. And how many Als do I have? I've got 2 of them here. And then the anion goes next, O. And how many O's do I have? I've got 3. So the compound that forms between aluminum and oxygen would be Al2O3. It works very much the same way if you are writing a compound that involves a polyatomic ion. Okay, remember we had the chart for polyatomic ions, and you can look up the polyatomic ions there. Let's say I want to write the formula for a compound that forms between sodium and hydroxide. Okay. Well, sodium, if you look at where it is an alkali metal, so it'll be a +1. And then you can consult your chart and see what's the charge for what a hydroxide is. A hydroxide is OH -1. Okay, so that's an oxygen and a hydrogen together in a polyatomic ion, and together they have a charge of -1. So I'm going to look at it and I'm going to say, okay, do they balance? How many of each do I need to balance? Well, here we have +1 and here we have -1. So they balance with just 1 of each. So let's go ahead and write the formula here. The cation goes first, and the anion goes second. And since there was just 1 sodium, I'm not going to write a number. Since there was just 1 hydroxide, I'm not going to write a number. So pretty simple there. Let's take a look at another one. And sometimes with these polyatomic ions, especially with the anions, they get a little bit tricky. Let's look at a trickier one. Okay, the tricky part happens when you need more than 1 of these polyatomic ions. So let's say I'm trying to write the compound between calcium and hydroxide. Well, calcium, like we mentioned, is a +2, and hydroxide, you can look up on the chart, is a -1. So do they balance? No, they don't. Which one do I need more of? I need more negatives. So let me add another hydroxide. Okay, now I've got 2 positives, I've got 2 negatives, they balance. So what we'll do, we'll write the formula. Cation goes first. And there's only 1 of them, so I'm not going to put a number there. The anion goes second. Okay. But now look at this. What a lot of people might be tempted to do is put a 2 right there, okay, to show there's 2 hydroxides. But what this is really saying is that there's 2 hydrogens and only 1 oxygen. If you look at what the ions are, we don't want just 2 hydrogens, we want 2 of this whole group. This whole group of OH, we want 2 of those. So if I put the little 2 there, that makes it look like it's just the hydrogen that there's 2 of. So what we do, if you have more than 1 of a polyatomic ion, we put parentheses around it. We put the number outside the parentheses. So if I have a compound forming between calcium and hydroxide, it's Ca parentheses OH2. And sometimes this gets to be looking kind of a little bit complicated. Let's do one more example here where we have a number in the polyatomic ion that we need more than 1 of, because people get confused with this, and I don't want you to get confused with this. Let's say I'm writing a formula for the compound that forms between magnesium and nitrate. Okay. Magnesium is an alkaline earth metal, has a charge of +2. Nitrate, you can look up on your chart there. Nitrate is NO3 with a charge of -1. You can see it's already got a number there in the ion, right? See, it's N with 3 oxygens. So there's already a number there in the ion. And you can probably see we're going to need more than 1 of them. So the charge is +2, the charge was -1. I'm going to need another one of these negatives. I need another nitrate. Now they balance. I got 2 positives and I have 2 negatives. So now we'll write the formula. We'll write that cation first. And since there's only 1, I'm not going to write 1. We'll write the anion next. And since there's more than one of that polyatomic ion, remember we have to put it in parentheses. Okay. And then how many of them are there? There's 2. So you can see sometimes people get confused because when there's a number in the polyatomic ion and then we have more than one of them, we have a number subscript kind of right next to a number subscript. Don't let that confuse you. This one tells you how many of the ion there are, and this one tells you how many of the oxygen atoms are in that polyatomic ion. So don't let that confuse you. So if we're forming a compound between magnesium and nitrate, Mg parentheses NO3 2. Again, just one more quick example of this, because we haven't done one with the transition metal. If you remember, the transition metals can form more than one ion, and it's really not that much more complicated with the transition metals because I will have told you what the charge is for it, right? So let's say we're forming a compound between copper with a charge of +1 and oxygen with a charge of -2, right? So the copper, like I just said, is going to be a +1. You know, copper can form an ion that's either +1 or +2, but I told you it was a +1. Okay. And then oxygen, the oxide, since it's a chalcogen, is a -2. Okay. Well, do they balance? Nope. Which one do I need more of? I need more of the copper. So let me add another copper. Now I've got 2 positives and I've got 2 negatives. Now they balance. So let's write the formula. Cation goes first. And I have 2 coppers. And then the anion goes second. And I have only 1 oxide. So between copper with a charge of +1 and oxygen, it's Cu2O. If I had, on the other hand, told you that it was copper with a charge of +2, that would be different. Copper with a charge of +2 already balances an oxygen, right? So here you would have Cu. So the 2 different ions will form 2 different compounds, right? So be careful of that. Okay, the last thing we want to be able to do here for us to talk about is how to say the names of these ionic compounds. And it's actually, if you remember how to name the ions, it's very simple, okay? The name of an ionic compound made up of 2 words. The first word is the name of the cation. The second word is the name of the anion, right? So if you remember, we talked about to name an anion, you take the name of the element and change the end of the word to "ide." To name a cation, it kind of depends on what it is. If it's a transition metal, remember it needs the Roman numeral to tell you what the charge is. If it's one of the other ones, we just put the word ion at the end, right? Well, we're not going to put the word ion in the names of the compounds here. We'll just take the element's name for the cation. So this first one, very simple. Na is sodium, S is sulfur, which as an ion we would change to sulfide. So the name of this one would be sodium sulfide. Okay, some of them that contain the polyatomic ions, you know, the polyatomic ion has a name. You can consult the chart and see what the name of the polyatomic ion is. For the second one here, the cation's name is magnesium, and then the anion, consult your chart, NO3 is called nitrate. So this one would be called magnesium nitrate. Okay, and then probably the trickiest example is when you have a transition metal involved there, okay? Because the transition metal needs a Roman numeral to tell you the charge, but the formula doesn't tell you the charge. It does, but it just doesn't directly tell you the charge, right? You got to figure it out. So if we take a look here, we've got 2 coppers and 1 oxygen. Obviously, the second word is going to be oxide, and the first word is going to be copper, but the name of that ion needs a Roman numeral. So it's going to be copper, some Roman numeral, oxide. So how do we figure out what that Roman numeral is going to be? Well, there's 2 coppers and there's 1 oxygen. If you look at where oxygen is on the periodic table, it's a +2. So the coppers, 2 coppers, have to balance a -2. So how much is each copper? Each copper's got to be a +1. So this copper ion is the copper 1 ion. So this will be copper, Roman numeral 1, oxide. Okay, so the process here is generally very simple, but what I see students do is they'll go through their assignment and they'll very easily name these ones and they'll very easily name these ones, but then they'll get to one of these and they just won't put the Roman numeral in there. You got to have that Roman numeral, and you're going to have to look at the formula and figure it out, right? See how many is needed to balance, what is the charge on that guy got to be to figure out the Roman numeral. And keep in mind, the Roman numeral is either going to be a 1, 2, or 3, like 99% of the time. It might be as high as 4, 5, or 6, maybe rarely. So generally, it's going to be like a 1, 2, or 3. Okay, so here's a challenge for you. What is the name of that compound? Go ahead, pause the video, figure it out, and then come back and see if you're right. Okay, so the Fe should be pretty obvious, is iron, right? And the PO4, if you look on your polyatomic ion chart, PO4 is called phosphate, and it has a charge of 3-. Iron can have a charge of either +2 or +3. So which one is it? Is it +2 or is it +3? Well, I don't know. Let's assume for a minute it was +3. Would that work? Well, then a +3 and a -3 would balance out. So we would have just one of each. We would have FePO4. Is that what we've got? It's not what we got. So it's not +3. Well, let's try the +2. Okay. Well, now they don't balance. So which one should I try more of? Let's try more of this one. Okay. They still don't balance. This is 4 positives and this is 3 negatives. Let's add another one of these. Still don't balance. That's 6 negatives and 4 positives. But if we add one more of these, then it's 6 and 6, they balance. Okay, so now there's 3 irons. Look at this, Fe3. There's 2 phosphates. 2 phosphates. So this iron must be iron 2. So what would be the name of that guy? That guy would be iron, Roman numeral 2, phosphate. There we go. Okay, so there's a bit about how to write the formulas and the names for some of these ionic compounds. Hopefully that helps us to be able to write the formulas and names for ionic compounds. So until next time, take it easy.